general solution of the ODE differential equation by the method of variation of parameters. So we have a non-homogeneous, second order non-homogeneous linear differential equation. Okay, to solve this, because this is non-homogeneous, we first consider homogeneous equation, corresponding homogeneous, okay, which is consider, just take right hand side 0, y double prime plus 16y equals 0. And to solve this homogeneous equation, we find characteristic equation, which is r squared plus 16 equals 0. Subtract 16 from both sides, take a square root, so r is plus minus 4i. And based on these two roots, we got two solutions. Let's say y1 is a 0, so e raised to 0t, which is 1, cosine 4t, so just cosine 4t. And second solution is sine 4t. Okay, these are two solutions. By the way, solutions of this homogeneous. If we plug in y1 here, y1 means y, y1 double prime plus 16y1, that will be 0, and same thing for y2. And from these two solutions we can write complementary solution. yc complementary solution is just c1 y1 plus c2 y2. And the general solution is in fact y equals complementary plus a particular solution. So the main issue here is to find a particular solution, and that will be just we vary the parameters c1 and c2. Okay, so based on this complementary solution, we let y, which is yp by the way, this is yp, we just vary the parameters or constants c1 and c2. Let's say this is u1 cosine 4t plus u2 sine 4t. Okay, this will be our yp, and y is now the final answer. General solution is yc plus yp, where we have yet to determine the values of the functions u1 and u2. Okay, so here the goal is to determine the functions u1 and u2. To make our work smoother or easier looking, so I'm going to keep this as y1 because this is our y1 anyways, and this is y2. Okay, so this one is in fact y1 and this is y2, or in fact I don't need here for yc, so I can just leave that, but for now I'm just writing y1 y2. Okay, now to determine the functions u1 and u2, so this yp is solution of the whole thing here, so we plug this y here. Plug y means 16y plus y double prime, so we need to find second derivative of this function plus 16y, that is in fact equals secant 40. From there we should be able to find u1 and u2. Okay, so this is y, so to plug here we need to find y prime and y double prime. So I'm writing y1 so that I don't have to find the derivative yet. We need to find derivative at some point, but for now just y1. So find the derivative. So here this is a product, so the derivative is derivative of using the product rule, derivative of first factor, leave second alone, plus derivative of second factor, leave first alone, plus same thing here, it's a product, so from the product rule, derivative of first factor, second, derivative of second factor, and first is just u2. Okay, let me erase this. Okay, so this is u2. Okay, so we are trying to determine u1 and u2, two unknowns, but we have only one condition because that equals secant 40. So when we have two unknowns but only one condition, that means we have one condition comes for free. Okay, the second condition comes for free. Generally, to find two unknowns, we have two conditions, but in this question we have only one condition. So to make our life easier, this u1 is unknown, so let's say this one and this one u2 unknown with derivatives, that's 0. Okay, so that comes for free. So u1 prime y1 plus u2 prime y2 equals 0, and I'm gonna say this is equation 1 for future reference. Why how we can write this? Because we have only one condition to satisfy, but we have two unknown variables because we are trying to determine u1 and u2. So this comes for free. So that makes y prime, this one plus this one is 0. So y1 prime u1 plus y2 prime u2. Okay, to plug in here we need to find second derivative, so let's go for that. So the second derivative is then again product rule. Okay, y1 prime prime y1 double prime u1 plus y1 prime derivative of this one plus here another product rule, y2 double prime u2 plus y2 prime u2 prime. Okay, now let's plug y and y double prime here. Plug in y and in fact y double prime. So what is that? Y double prime, which is here. So let me write here y1 double prime u1 plus y1 prime u1 prime plus y2 double prime u2 plus y2 prime u2 prime. That's y double prime plus 16y. Okay, so y is here. We said u1 y1 plus u2 y2. So 16 times, so we need to distribute 16 into these two terms. So u1 y1, and by the way y1 is cosine 40 and y2 is sine 40, those are knowns. Okay, plus 16 u2 y2. Okay, that's u2 y2, that is equals secant 40. Now because the original equation was y double prime plus 16y equals secant 40, we first solve the homogeneous. Okay, we just said 0, and from there we found two solutions, y1 and y2. That means y1 double prime plus 16y1 is 0. Same for y2. y2 double prime plus 16 y2 will be 0, and that will be the case. From these two we can factor u1 out, that leaves y1 double prime plus 16 y1, and this one is 0 because y1 is solution of the corresponding homogeneous. In the same way, y2 double prime, factor u2 out from these two, y2 double prime plus 16 y2, that will be 0 as well because y1 and y2 are solutions of this, plus what is the remaining now? Here I'll write u1 first, so u1 prime y1 prime, this one, and here plus u2 prime y2 prime, and the right hand side is secant of 4t. Now this one goes to 0 because y1 is solution of this homogeneous, and same thing here. Okay, so let me erase this. Now, so this equation, when we plug in, it becomes now u1 prime y1 prime plus u2 prime y2 prime equals right hand side, which is secant 4t. Now this is second equation. So in fact, whenever you plug in these things, this will be always the case. The first one is equation 1, u1 prime, let me write side by side, equation 1, that was u1 prime y1 plus u2 prime y2 equals 0. That we assumed to make our life easier. Okay, that is always the case. And after plugging in, we have this situation. Now we want to solve this. So we can just use algebra from algebra 1, just method of elimination. Okay, remember we are trying to determine u1 and u2, but the primes, the derivatives are here. That means we solve for u1 prime, then integrate to get u1. So let's get rid of u2 prime. So u2 prime y2 prime, so we want to multiply by something so that when we subtract, gets cancelled. Okay, so y2, now I want to multiply this by y2 prime. Okay, multiply this equation by y2, this by y2 prime, then subtract. Okay, let's do it. Then that way, what happens here now? u1 prime y1 prime, we are multiplying by y2, and this one will be same, but we subtract means minus, so it gets cancelled. Here minus u1 prime y1 y2 prime, because we are multiplying second equation, in fact number 1 equation, by y2 prime, and these two gets cancelled, equals y2 secant 40 minus that 1 times 0 is 0. Okay, now look at here, y u1 prime, we can factor that leaves y1 prime y2 minus y1 y2 prime equals y2 secant 40. Then u1 prime is in fact y2 secant 40 over y1 prime y2 minus y1 y2 prime. Remember, the y1 was cosine 40 and y2 was sine 40. So let's use them here. So u1 prime is now y2 is sine 40. Okay, secant 40 is, in fact, secant is reciprocal of cosine. We can write, if we like, 1 over cosine 40. On the bottom, let's work here, and it's going to be a nice number. You will see y1 prime. So derivative of cosine 40 is negative 4 sine 40. Derivative of cosine is negative sine and 4 times y2. y2 is sine 40 times sine 40. So that's sine square 40 minus in the middle. y1 is cosine 40 and y2 prime derivative of sine 40 is cosine 40 times 4. So 4 cosine 40 and times y1 is cosine, so cosine square. So the bottom is negative 4 sine square 40 minus 4 cosine square 40. We can combine, we can factor negative 4 out. That leaves sine square 40 plus, because negative 4 is out, cosine square 40. Negative 4 times sine square theta plus cosine square theta. Whenever we have same angle, that is 1. So negative 4 times 1 is negative 4. So the bottom is just a number. Nice, that's just the negative 4. So u1 prime is, in fact, we got sine over cosine. Negative 4 can be pulled to the front. Negative 1 over 4 sine 40 over cosine 40. That's u1 prime. Now to find u1, we need to integrate both sides. Okay, let's integrate. Then u1 is, when we integrate here, negative 1/4 can be pulled to the front. Sine 40 over cosine 40, obviously with respect to t. And now this is a fraction, so we need to go for u substitution. U is bottom, u is cosine 40. Okay, derivative of cosine 40 is what? Negative 4 sine 40. Bring this to the front, so du over negative 4 sine 40 is dt. So dt is this. So we can write this as negative 1 over 4 sine 40 is as it is. Cosine 40 is u. Dt is here du over negative 4 sine 40. Is to cancel. Negative 4 can be pulled to the front, or negative 4 means 1 over 16. 1 over u du, 1 over 16 natural log of u, and u happens to be cosine 40. Plus c, no need, we just want to write down a general, the easiest function. So this is how we find u1. Okay, it's a long problem. Then from the same equation 1 and 2, we cancelled second factor and we were able to find u1. Now we multiply in the same way, try to cancel the first, then we will find u2. Go back here, so I'm gonna do the same thing, but I'm gonna multiply slightly different way. I am planning to cancel these now. So y1 prime, y1. So I'm going to multiply by y1, multiply by y1 prime, and subtract. That way I can cancel first terms. Okay, so that will be, what is that? u2 prime from the equations, again, 1 and 2. We get, after multiplying by this, so u2 prime y1 y2 prime, u2 prime y1 y2 prime, so minus, the first terms cancel here, u2 prime y1 prime y2, u2 prime y1 prime y2 equals, okay, right hand side is y1 secant 40 minus the bottom is 0. Okay, like in the previous, we can factor u2 prime out, that leaves y1 y2 prime minus y1 prime y2 equals y1 secant 40, divide by this. So okay, this is, I meant u2 prime, not y. Okay, so u2 prime is y1 secant 40 over this y1 y2 prime minus y1 prime y1 prime y2. So like here I did this thing, because our y1 is cosine 40, by the way, y1 is cosine 40 and y2 is sine 40. When you find this one, y1 y2 prime minus y1 prime y2, so you work out, it's gonna be 4, okay, after some work. So this is 4, so u2 prime is, y1 is cosine 40 times secant 40, and we can simplify the top as well. y1 is cosine 40 times secant 40 is 1 over cosine 40. They also cancel, so that's 1. So this product is 1 on the top, and this is 4 when we do this work. Okay, this is like here. Oh, that's nice. So u2 prime is 1 over 4, then u2 is just integrate. Constant means constant t, 1/4 t. Okay, now we got u1 and u2. Then we can find the particular solution. What is that? u1 y1 plus u2 y2, which is, okay, u1 is found here, 1/16 natural log of cosine 40, yeah, that times y1, and y1 is cosine 40 plus u2 we just found here, 1/4 t, and y2 is sine 40. Okay, this is yp, and we found yc, complementary solution, at the very beginning. u1 y1, sorry, c1 y1 plus c2 y2, that's complementary solution, and complementary plus particular is the general solution. So general solution is then y equals yc, which is c1 y1 c2 y2 plus yp, and yp is given here. Okay, you just want to copy this here, where yp is here. Okay, you just want to copy, or just right there, final.